Imagine your body as a vast, bustling country where each organ is like a unique city with its own special function and personality. Your heart might be the capital, always working, while your lungs are the busy ports, exchanging oxygen and carbon dioxide. The brain is the command center, and the liver is the industrial hub, processing and filtering. All these cities are connected, working together to keep the country, your body, running smoothly. Now, picture the blood vessels as a complex network of highways and roads, transporting vital supplies like oxygen, nutrients, and hormones to every corner of this country. These highways are always busy, ensuring that every organ gets what it needs to function at its best. But just like any country, your body needs a defense force to protect it from invaders. That's where your immune system comes in, a highly trained, ever-vigilant army, always on the lookout for threats. This microscopic army is made up of a variety of special cells and powerful proteins, each with a unique role. They patrol every inch of your body, from the surface of your skin to the deepest parts of your bones, always ready to spring into action. Their main mission? To distinguish between what belongs in your body and what doesn't, to tell friend from foe, and to act quickly if something seems out of place. Every cell in your body wears a unique molecular ID tag, like a passport, that tells the immune system, I'm one of you. These tags are made of proteins and other molecules on the cell's surface. Immune soldiers constantly check these IDs. If a cell's ID matches, it's left alone. But if the ID is missing or looks suspicious, like those on bacteria, viruses, or other invaders, the immune system attacks swiftly and decisively. When an invader is detected, the immune system doesn't just attack. It also sounds the alarm, sending out chemical signals to call for reinforcements. This rapid response helps contain threats before they can spread. Some immune cells are fierce warriors, attacking and destroying invaders directly. Others act as scouts and analysts, gathering information about the enemy and sharing it with the rest of the immune system to coordinate a more effective defense. Perhaps most impressively, some immune cells act as memory keepers. They store detailed records of past invaders, so if the same threat returns, your body can respond faster and stronger. This is the principle behind vaccines. They train your immune system to recognize and defeat specific enemies before you ever get sick. Day in and day out, your immune system is hard at work, fighting off countless threats you never even notice. It's a silent guardian, always on duty, keeping you healthy without you having to think about it. Beyond fighting infections, the immune system also cleans up damaged or dead cells, helping to heal wounds and maintain balance. It's like a peacekeeping force, making sure everything runs smoothly inside your body. Without this incredible system, even a tiny paper cut could become a life-threatening infection. The immune system is what stands between you and a world full of microscopic dangers. The immune system is your ultimate guardian, a marvel of biological engineering, tirelessly protecting you every moment of your life. Next time you recover from a cold or heal from a scrape, remember the invisible army working behind the scenes to keep you safe. Imagine your immune system as a highly trained army, always on the lookout for invaders like bacteria and viruses. Its job is to protect you, to keep you safe from anything that doesn't belong. But what if, one day, this army got its signals crossed, became confused about who the real enemy was? Instead of defending the borders, it suddenly turned its weapons inward, attacking its own people, your body's healthy cells and tissues. This is the essence of autoimmunity. The immune system, designed to protect, mistakenly targets the very body it's meant to defend. It's as if the guards at the gate can no longer tell friend from foe. Instead of fighting off harmful invaders, the immune system launches attacks on healthy organs and tissues. Sometimes the pancreas, sometimes the nerves, sometimes the skin, or even multiple places at once. And this isn't just a single mistake. It's a relentless, ongoing campaign. An internal siege that can last for years or even a lifetime. There are more than 100 different autoimmune diseases, each one defined by which part of the body is under attack. Some target a single organ, while others affect many systems at once. For example, when the immune system attacks the joints, it's called rheumatoid arthritis. If it targets the skin, it's known as psoriasis. When the thyroid is attacked, it leads to Graves' disease. Each condition has its own symptoms and challenges. The result? Chronic illness that can affect every aspect of life. People with autoimmune diseases often experience constant internal conflict, unpredictable symptoms, and a deep, unrelenting fatigue that rest can't fix. It's like having a civil war inside your own body, your immune system always on high alert, never able to stand down, always fighting a battle that never truly ends. The very cells meant to protect you become your attackers, draining your energy, causing pain, and making even simple daily tasks feel overwhelming. In autoimmunity, the body is locked in a battle it can't win, because the enemy is itself. Understanding this process is the first step toward finding hope and better treatments for those affected. How does this happen? It starts with immune cell training. In the thymus, young T cells are taught to recognize self from non-self. If a T cell reacts to self, it's destroyed, a strict quality control. Over 99% of potential troublemakers are eliminated. But the system isn't perfect. Occasionally, a rogue T cell slips through. This sleeper agent can recognize and attack the body's own tissues. For years, it may do nothing, until it's activated by the right signal. The safety net failed in a tiny way, but the consequences can be huge. One rogue cell, given the right circumstances, can trigger disaster. The stage is set for autoimmunity. All it takes is a spark. A rogue T cell alone isn't enough for autoimmunity. The body's immune system is a complex network, and a single cell going astray doesn't usually cause chaos on its own. Our bodies have many checks and balances to keep these cells in line, preventing them from attacking healthy tissue without reason. You need a perfect storm: genetics, an environmental trigger, and a dash of bad luck. It's like 3 puzzle pieces coming together at just the wrong moment. Each factor alone isn't enough, but together they can tip the balance and set the stage for autoimmunity. Some people inherit genes that make their immune systems more aggressive or less able to distinguish friend from foe. These genetic differences can make certain individuals more vulnerable, priming their immune cells to react more strongly to threats, or even to things that aren't threats at all. Then comes an infection, like the flu, a stomach bug, or even a seemingly harmless cold. That puts the immune system on high alert. The body's defenses ramp up, sending signals to immune cells everywhere to be on the lookout for invaders. During this chaos, the rogue T cell might get activated. It's as if the immune system's alarm bells are ringing so loudly that even the cells that should stay quiet get swept up in the response. The final ingredient: molecular mimicry. This is when a germ's protein looks almost identical to a protein found in our own bodies, like 2 puzzle pieces that fit together perfectly. Some germs have proteins that look so much like our own that the immune system can't tell the difference. It's a case of mistaken identity at the molecular level. If the immune system mistakes a germ's protein for a self-protein, it can activate the rogue T cell. Suddenly, the body's own defenses are turned against itself, targeting healthy cells as if they were invaders. Suddenly, the immune system clones an army to attack that shape, unaware it's attacking the body. What started as a defense against infection spirals into a full-blown assault on the body's own tissues. The result: a devastating assault on healthy tissue. This is how autoimmunity begins. The body's protectors become its attackers, causing pain, inflammation, and lasting damage. Genetics, infection, and chance combine to unleash autoimmunity. It's a rare and unpredictable collision of factors, making it difficult to predict or prevent. Sometimes it's just bad luck. Even with all our scientific knowledge, there's still an element of randomness, reminding us how delicate the balance of our immune system truly is. Take type 1 diabetes, a classic case of friendly fire. Here, the immune system targets the pancreas's beta cells, which make insulin. Insulin is the key that lets sugar into cells for energy. Without it, cells starve, no matter how much you eat. A genetic predisposition and a viral trigger can set off the attack. T cells invade the pancreas, silently destroying beta cells over months or years. When enough cells are lost, symptoms appear: high blood sugar, fatigue, thirst, and hunger. The immune system's attack causes a metabolic crisis. People with type 1 diabetes must replace insulin for life. It's a sobering example of autoimmunity's precision. The body's defense system becomes its own worst enemy. Multiple sclerosis, or MS, is another example. Here, the immune system attacks myelin, the protective sheath around nerve fibers in the brain and spinal cord. Myelin is like insulation on electrical wires. Without it, nerve signals get scrambled. Symptoms depend on where the attack happens: vision loss, numbness, weakness, memory problems. MS is unpredictable, with flare-ups and remissions. Over time, repeated attacks cause permanent nerve damage. The immune system severs the body's own lines of communication. MS is a slow, unpredictable disconnection between brain and body. It's a heartbreaking example of the immune system gone awry. The body's own defenses create chaos within. Some autoimmune diseases like lupus attack everywhere. Lupus is systemic. It can strike almost any organ or tissue. The immune system produces antibodies against the cell nucleus, so no part of the body is safe. Symptoms vary: joint pain, skin rashes, organ damage. The disease can mimic many others, making diagnosis tough. The problem starts with faulty cleanup of dead cells. The immune system overreacts to exposed DNA. Autoantibodies trigger inflammation and damage throughout the body. Living with lupus is like facing an unpredictable internal enemy. Treatment often means suppressing the immune system, which increases infection risk. Lupus is the ultimate example of a defender-turned-destroyer. The body becomes its own battlefield. If autoimmune diseases are so harmful, why do we still have the genes for them? The answer: evolution's trade-off. The same genes that raise autoimmunity risk once helped our ancestors survive deadly infections. In a world of plagues, a hyper-vigilant immune system was a lifesaver. DNA from plague survivors shows these strong immune genes were more common. The risk of autoimmunity later in life didn't matter if you didn't survive childhood infections. These aren't bad genes. They're powerful immune response genes, adapted for a different era. We carry the legacy of survivors, for better and for worse. So why are autoimmune diseases rising now? Our environment changed faster than our genes. We have antibiotics, vaccines, and sanitation. Our immune systems face fewer real threats. The hygiene hypothesis suggests that without enough early exposure to germs, our immune systems become restless and overreact. Our powerful immune army, built for war, now has little to do and sometimes turns on us. The paradox: our medical triumphs may have created the perfect conditions for autoimmunity. We carry ancient genes in a modern world. Understanding this mismatch is key to finding new treatments. Science must find ways to retrain and calm our internal guardians. For science,